Hey and welcome back to this video, which is a quick introduction to WebRTC. In this video, we will take a look at the WebRTC components and see how the connection flow goes. If you want to see more tutorials about video calls, streaming and other stuff, make sure you will subscribe to my YouTube channel. So what is WebRTC? If you want to create a video call or voice chat or even streaming services, you want to use WebRTC. But how we are going to do that? We need to know how two connections are going to connect to each other and send and receive the streams. So to do that, you need to know answer for these two questions. First is what to exchange and then how to exchange. So to establish two connection between two peers or two users, you have to exchange two types of packages. The first one is session description protocol, and the next one is ICE candidates. So WebRTC relies on two key pieces of information to establish the connection. We will for sure take a deeper look in this about how to exchange question. Actually, you have to provide service for these two peers to exchange their data. So at the beginning, they don't know each other. They want to have a direct call between each other. And you have to provide a way to exchange the ICE and STP protocols. So you can do that by creating a WebSocket or HTTP server. It's all on you. Let's take a deeper look in the session description. Session description is an standard format for describing the communication session. There are many types in this description. We will explain about our media type, which it could be audio or video data, the codecs that are going to be used, for example, Opus or H.264, and the network details, including the IP address and the ports for sending and receiving media, and bandwidth information to specify the limits on the data rate for the connection. So here is an example of the SCP. You'll see there are some parameters with the starting letters that will describe how is our session description. Let's take a deeper look in this. Right here, V stands for version of this SCP. O stands for original field containing a unique ID session and IP addresses. And the S is for session name and other stuff. M, A, you can see that they are talking about the description of the media and the codecs. The next thing is ICE or interactive connectivity establishment. After knowing the description about the session, we have to find the best path for the communication. So ICE candidates represents potential network route between peers. And it also includes the host candidate, which is the local network addresses, the server reflexive candidates, which is the public facing addresses discovered via stun, and relay candidates that are the addresses provided by turn server, which we'll be talk about it a little bit on the upcoming slide. And here is an example about the ICE candidate. Let's take a deeper look inside it and see what's all of them about. So you'll see it start with candidates. And after that, here is an identifier for the candidate. And this small number is talking about the streaming protocol, which is RTP or RTCP, and the type of the packets, the protocol that we are using at the moment, and the IP addresses of the candidates, the ports, and the type hosts, and other stuff that are going to generate automatically that you don't have to do anything for most of the parts. And let's move to the second question, that how to exchange. As I said before, you basically need a way or a path to exchange these data between two peers. You can use the socket or HTTP server, it doesn't matter at all. All you have to do is to exchange these data between two clients. For example, if Bob wants to create a call to Alice, he has to send an offer to the signaling server. So signaling server knows who to forward this packet, and it will forward this packet to the Alice. Alice will get the offer, set it as the remote description, and it will generate its own answer. So the answer is going to be sent to the signaling server and it will be received by the Bob. Meanwhile, there are some ICE candidates being generated that will be transferred to each other. You can see it goes both ways. After exchanging these packets, the peer connection will be established. Simple as that. So here's an example of the signaling server. You can see we have a listener called onMessage using our signaling server, which is the circuit right now. And we will parse the data and check if the data type is STP. We want to set it as the remote description. And if it is the ICE candidate or ICE candidate, we want to add it to our peer connection. Simple as that. But right now, there are some issues to establish this direct call or direct connection because your device is actually behind the router in most of the times. For example, if you have a mobile phone, it's connected to your router, so your public IP is not accessible. And for that, you need to use some services which is called STUN that provides you your public address. So network address translation or NAT and firewalls can obstruct peer-to-peer connection in WebRTC. And what is the NAT? It actually allows multiple devices on a local network to share a single public IP address. And user behind the router will have the private IP addresses, and data is transferred from the router to the public address. So this creates complications when peers attempt to communicate directly with one router. As their private IP addresses are not routable over the internet, to find a solution, WebRTC uses stun and turn server. So let's take a look what are these two things. Stun server or session travel utilities for NAT help WebRTC clients to discover their public-facing IP addresses, which are necessary for peer-to-peer communication when devices are behind the NAT. And the turn or travel using relays around the NAT is actually when the direct peer-to-peer communication fails, for example, staying behind the symmetric NAT, turn servers are used to relay traffic between peers and ensuring that the connection is maintained. Here's an example of the stun server and turn server. You can see stun server starts with this stun and turn start with the turn, and it in most of the cases has the username and credential or the password. And they are both called IC servers because they are in charge of finding a proper route between two peers. Okay, that's a quick introduction to WebRTC. If you want to implement these kind of features or you want some consultancy, leave it to the experts. Till the next video, see you.